Okay, we're at the fourth and last part of our tutorial series on developing a stylized paint utility shader in Unreal Engine. In the first, second, and third part of this series, we took care already of the base color, specular, stylized shadow, and outlines. And in this last part, we will be adding some nice final touches, like some smudginess around our sphere, as well as some sketch rims. Okay, let's get right into it.
All right, so at this point, I think we can start adding a little bit more noise at the outline of the sphere. And I want to add something like an outer rim erosion, something as if there were more scribbles coming out of the mesh. This outer rim will basically act kind of like an outline, so it won't be part of the solid mesh. For this to work, we need to add one more instance static mesh. So this is getting a little bit messy, so I'm just gonna start adding comments. I'm going to select the first two nodes and then comment them as diffuse. Then I'm going to select the last four ones and I'm going to call it outlines. Now, since these instance static mesh noodles are all over the place, I'm going to add this. I'm going to connect it to the instance static mesh nodes directly, like so, and like so. I'm going to add a little bit of reroute nodes here, and then just a reroute node here that is going to work for both the outlines. Perfect. Now, before the outlines are created, I want to add the eroded rim. So I'm just going to select the instance static mesh component, the add instance, and the custom data value, as well as the reroute node, copy, and then paste them down here. Then I'm going to plug the execution pin from the first set custom data value to the add instance node down here, and then just connect the second set custom data value to the third add instance. Okay, I'm going to make a little bit of space. And then I'm going to select this group of nodes for the outer eroded rim and then comment it into outer eroded rim. And let's not forget to plug the instance transform from the get relative transform into the instance transform down here. Okay, perfect. So these are all the same custom data index. So the custom data index 0, but I'm dictating three different things. I'm dictating the diffuse, the eroded rim, and the outline. So I actually need three different values to distinguish them. So I'm going to leave the outer eroded rim at 1. And then for the outlines, I'm going to set a custom data value of 2, actually. Okay, then I'm going to compile and save. So now the custom data values of 2 will dictate the outlines, the ones of 1, the outer eroded rim, and of 0 of the diffuse. Let's go back to our material. So I have created a useful material function to isolate these three different custom data values, and that's called mf switch by instance data. If we double click on it and open it up, you can see here that we have two if nodes, and then we have two different outputs. One defines the base versus the rim, which is the outer rim, and one is the base with the rim with the outline. The output is still going to be 0 or 1 because we needed to be driving the lerps, but we can use these two different outputs to define whether we are in the base, the eroded rim, or the outline. So let's go back to our painterly material and include this into our setup. First of all, the switch by instance data material function needs a per instance custom data node to work. And at this point, we're talking about having a different type of inflation for the eroded rim and for the outline. So we're going to create one more scalar parameter, and we're going to be calling it outer erosion strength. And that's going to define how much the eroded rim is going to be expanded from the base mesh. And the default value, I'm going to set it to 1. And then we're going to be adding a lerp, and we need to check whether this is the rim or the outline. So let's take the second pin and plug it into the alpha, and then the outline's general offset to the B, and the outer erosion strength to the A. And then plug the lerp output pin to the multiply. Okay, so now we're going to have two different expansions based on whether we're talking about the eroded rim or the outline. Let's apply this switch by instance data to the other areas of the graph where we use the instance custom data now. So I'm going to go to the inflate here, and I'm going to do the same thing. Out of the per instance custom data, I'm going to add the mf switch by instance data. And here we're checking whether we're dealing with the base mesh or the rim. So we're going to plug the base versus rim into the alpha. And also, now that I'm here, I'm just going to select all these nodes and comment them to inflate. Okay, where else have we used the per instance custom data? I can see it here in the outline mask. Out of the per instance custom data, we're gonna add a switch by instance data. And here we're checking again whether we're talking about the eroded rim or the outline. So out of combined versus outline, I'm gonna plug this into the alpha. And we also use the per instance custom data here to drive the outline opacity mask. So out of this per instance custom data, I'm gonna add a switch by instance data. And again, here we're checking whether we're talking about the eroded rim or the outline. So I'm going to plug that into the alpha. And then the last one we added was up here into the shadows. So out of the per instance custom data, I'm just going to add a switch by instance data. And then I'm checking whether I'm talking about the base to cast the shadow or the rim. And I'm going to plug that into the alpha. So now if we did everything correctly, nothing should change. So if we save and go back to our painterly material in the viewport, everything should stay exactly the same. Perfect. So before we get into our Eroded Rim, I just realized we haven't set up a way to define a different color for the outlines. So let's do that now. I'm going to go back to the painterly material. And then here in the diffuse, I'm going to add another lerp. I'm going to plug the diffuse into the A, and then I'm going to get a per instance custom data. I'm going to plug it into a switch by instance data. And then we're checking whether we're in the combined, so in the eroded rim or the outline. And I'm going to plug that into the alpha. Then I'm going to create a vector3 node that I'm going to convert to parameter. And I'm going to call this outlines color. And I'm going to leave it black because I like a black outline. And then plug it into the B of the lerp, and then the output of the lerp into the base color. So now if we save, we will see that we will have black outlines to our material. Okay, so now let's take care of our erosion. Let's make a little bit of space. So I'm going to select the outline mask and the inflate settings, and I'm going to drag them down. So for the outer rim erosion, we can use similar settings to the inner rim. So I'm going to select the vertex normals, the curvature filter, camera vector, component mask multiply, the texture sample, dot product, absolute, add, multiply, saturate, power, the other multiply node, and the step. Okay, perfect. I'm going to Control C and then Control V down here. Awesome. We're just going to have different settings here for the add and the multiply. That's just going to give it a different look. So on the add node, I'm going to have a value of 0.1 rather than 1. And then on the multiply, I'm going to have a value of 1.5. The power is going to have an exponent of 1. And then basically here, we want to be multiplying the alpha mask of our brush strokes with the power node. And we want to promote the b value of this multiply to a tiling. So I'm going to call this outer erosion tiling. I'm going to give it a value of 10. So this step is going to have a value of 0.2. And after that, I'm going to saturate. Okay. And I'm just going to start previewing the node. So basically, I want to have this eroded effect on the outline rather than the inside of the sphere. So I'm just going to be inverting this, adding a 1 minus node right after the saturate. I'm going to give it a little bit more space here. At this point, we want to multiply, like we did with the inner erosion, the 1 minus node with the curvature filter. And then we want to subtract from it the outline mask. So I'm going to add a subtract node. I'm going to get from here the outlines, and then I'm going to subtract it to the output of the multiply node. And if I start previewing it, you will see now that we will get this chipped effect. So I'm going to stop previewing the node, and I'm going to saturate this. And then I'm going to invert this mask again. So I'm going to plug the output of the saturate into the alpha. And then the A is going to be 1 and the B is going to be 0. So what we get from this is the inside white and the outline black. So I'm just going to make a little bit more space over here. Okay, now in order not to get the shadow of this eroded rim onto the solid instance static mesh, we will use the technique we used initially for the basic outline. So I'm going to right click here and add a two-sided sign to check which side of the polygon face is currently being rendered. If it's the front face, it's going to give me a value of 1. If it's the back face, it's going to give me a value of -1. And then I'm going to invert this to a 1 minus. And I will be multiplying the output of this lerp with the inverted normals. And after that, we will have our outer eroded rim set up. So I'm just gonna drag it off the multiply and add a named reroute decoration node that I'm gonna be calling outer eroded rim. Okay. And then I can select all these nodes and comment it outer eroded rim and then show the bubble. Okay, at this point, I will need a bit more space here because we need to add the outer eroded rim to our opacity mask. So right before the outlines, I'm going to copy the per instance custom data and the switch by instance data. And I'm going to paste them here. I'm just going to put them vertically to have a bit more space. And then I'm going to add one more lerp. So let's plug the switch by instance data base versus rim. So we're checking, is this the base or the outer rim? We're going to plug this into the alpha. And then the inner rim erosion output is going to go into the A of the lerp. And the B is going to be the outer eroded rim. And then we can plug the output of this lerp into the A of the lerp defining the outlines. And now if we did everything correctly, if we saved and went back to our blueprint, we will be seeing the outer eroded rim on our sphere. And of course, if we go to our map, we will see them there as well. All right, at this point, we're almost at the end of our tutorial. We just want to add some finishing touches. So basically, if we were a painter or a draftsman and had drawn this sphere, then we would perhaps have smudged a little bit the outlines of it. So we have something like a sketched out look on the sphere, but I think we can push this a little bit further and make it look as if the paint or the color of the sphere had smudged a little bit out of it. This approach is heavily inspired from the shell-based approach from Aku because we're literally going to be creating a lot of shells on top of each other, slightly offset from one another with some dirt texture on it. All right, so let's take care of it by going into the blueprint actor. And then in the construction script, we're going to be adding a lot of shells in here. So let's make some space. So I'm going to drag down the outer eroded rim and put this like here. Okay, so we're going to be adding 4 shell layers, and we're going to need to output multiple custom data values because we're going to be driving different values and just shift them a little bit in order to create this smudged effect. So let's copy this instance static mesh, the reroute, the add instance, and the custom data value, and then paste it down here below. And then we want this custom data index to have a value of 1. So it's going to be different from the one driving the diffuse, the outline, and the outer eroded rim. I want to duplicate it one more time and then get this instance static mesh target over here and get the instance index down here. I'm just going to make it a little bit more organized because we're going to be duplicating it multiple times. And now the second one is going to have a custom data index of 2. Okay, let's duplicate this again and plug it in here. The third one is going to have a custom data index of 3. Let's duplicate this again and custom data index of 4. And then one more time. This is the last one. And then a custom data index of 5. Okay. Okay, so we've added 5 more custom data indexes and we need to let the blueprint know. So I'm just gonna select the instance static mesh and then isolate the modified properties, which gives me directly this number of custom data floats. And I'm gonna set it to 6 because we added 5 more. Okay, then I'm gonna unflag the show only modified properties and compile. So let's start specifying what all these different custom data indexes will do. The first one is going to be for the inner erosion tiling. So we're going to be defining a different tiling for the inner erosion. The second one is going to be the inner erosion strength. So a different strength for the erosion. The third one, inner erosion area. The first one, inflate base amount to define how much this shell is going to be inflated compared to the diffused mesh. And then the fifth one, inner erosion mask. And we're going to say, just to make us understand what's going on, one is for the shells. Okay, we're going to have to plug all these custom data indexes into the Bentley material. But now, just to have some custom data values to see something going on, I'm going to add in the first one a custom data value of 1.4, the second one a custom data value of 10, the third one a custom data value of 1.9, the fourth one custom data value of 0.2, and the fifth one of 1, which is for the shells. Okay, so at this point, we want to plug the execution pin into the first shell. And before we start duplicating them, I just want to show you what the first one does. So let's first set up the material. Okay, so let's plug the execution pin to the outer eroded rim. And then let's not forget to plug the instance transform into the instance static mesh for the shells. Okay, so if we did everything correctly in the viewport, nothing should have changed, and it didn't. Okay, so now let's go into our material and start setting up all these different custom data floats. So first of all, let's just make a little bit of space for a shells layout node. So I'm just gonna select anything below the shadows, as well as my material domain and all these nodes. I'm gonna drag them down. And then in here, I'm gonna add the material function animated UV. I'm not gonna add the name reroute decoration node for the animated UV because I want to be able to change the tiling of this material function. So in here, the step time, I'm just gonna go up here and copy the step time and UV step size parameters that we have already exposed. And then I'm gonna paste them in here. Okay, so let's plug the step time into the step time, the UV step size into the UV step size, and the tiling is going to be our first per instance custom data. And the data index for the tiling, if we go back to our construction script, the inner erosion tiling would have a data index of 1. So let's set the data index to 1 and then plug the tiling into the S. And just to make sure we see the texture, let's make sure that the default value is actually 1. After that, we're going to add a texture sample. And we're actually going to be borrowing a texture from Aku's shell project, which is called T underscore brushstrokes. Okay, so this texture is just a grayscale texture with like different brushstrokes normals. Okay, at this point, we want to be multiplying this texture for another custom data. So let's add a per instance custom data here. And we're going to give it a default value of 10. And the data index would be 2 because this will take care of the inner erosion strength. So we're going to divide this for a value of 10 and then add a power node to make it a little bit softer with an exponent of 2. And then plug it to the multiply node. At this point, we need to create something similarly to what we did with the inner and outer rim erosions. So we're going to get our camera vector and we're going to use it with the dot product, not of the vertex normals, but of the pixel normals. Then we want to have a power node of 2 to soften this one a little bit out. Then we want to add it to one more instance custom data. So I'm going to get another instance custom data. This time is going to be the data index of 3. And I'm going to give it a default value of 0.8. Then I'm going to subtract from it 1 and plug this to the add node. At this point, we can add the multiply node with the add node. We can add another divide node, just divide it by 2. And if we start previewing the node, we can see that this kind of looks like our inner rim erosion, but with a different texture, and it is animated. Let's just clamp or saturate this node and then invert it because we want just the outline of these shells to be exposed. Okay, this is our setup for the shells. So I'm just gonna select all the nodes and then comment shells. And at this point, we want to include it into our inner rim erosion. So let's add a multiply node and then multiply the shells output with the inner rim erosion. Okay, and we want this mask to be applied only on the shells. So I'm gonna add another lerp node. I'm gonna plug the multiply into the B, and into the A, I'm gonna apply the normal inner rim erosion. Okay, and then in here, I wanna get another per instance custom data, which is gonna have an index of 5. And this one is gonna drive whether we're talking about the inner rim erosion or the shells. So I'm gonna plug it to the alpha. Okay, so let's make a little bit of space. I'm just gonna drag this a little bit to the side here because we're gonna be plugging the output of the lerp to the A right before we take care of the eroded rim. Okay, now we need to take care of a few other things. So first of all, let's take care of the inflate amount because we want to be inflating the shells differently than the outline or the outer rim erosion. So I'm just gonna expand this a little bit. And then before we get into this lerp, I want to have a multiply here. I want to multiply the normalize with a per instance custom data with an index value of 4. So these normals will revert to 0 unless this per instance custom data is set to 1. And then I'm going to plug it into the A of the lerp. Okay, now let's take care of our shadow because we don't want the shells to be casting any shadow. So let's go up here. Actually, we'll need to make a bit more space. This is getting kind of big. Okay, so let's expand this a little bit further. And before we get into the lerp, we want to do something else. We want to get an if. So let's plug the switch by instance data into the A of the if node. And then let's get another per instance custom data with the index value of 1. Plug this into the A of another if. We're using this just to check whether we are dealing with shells or not. So let's add 2 constant values by pressing 1 on the keyboard and clicking in an empty area of the graph. The first one is going to be a value of 2 and the second one a value of 0. Let's plug the 0 value to A less than B and A equals B and the constant value to A greater than B. Then the if output will need to be connected to the B of the second if output. And let's create 2 more constant values. Now, the first one is going to have a value of 1 and the second one a value of 0. If A is greater than B or less than B, I'm going to have an output of 1. And if it's equal to B, then I'm going to have a value of 0. So basically here I'm checking whether we're dealing with the base or not. And in any other case, I want to have a value of 0. And if we're dealing with the outer rim, the outlines, or the shells, then I'm going to have a value of 1 and not cast any shadows. Okay, now let's go into the inner rim erosion because we want to have a different tiling for the shells. So let's get the per instance custom data and we want to add the inner erosion tiling to the per instance custom data with an index of 1 and a constant default value of 1. And we're going to plug that directly into the multiply. So basically, we're just adding multiple parameters that are going to help us diversify the different shells. Okay, and that should be it. So I'm just going to save and then go back to my blueprint in the viewport. And you can see here that we start having a little bit of this smudged look on the outside of our sphere. So I'm just going to add 4 more of those. And this is going to really give this smudged effect. So I'm going to go into my construction script. I'm going to select all these nodes, and then I'm going to duplicate them. 1, 2, I'm going to give it a bit more space. Duplicate this again. So I'm going to duplicate it 3 times to have 4 different rounds of shells in total. And then I'm going to be plugging all the execution pins here. Okay. Oops. And into the outer eroded rim as well. I'm going to add here a reroute node. Okay. And then let's make sure to connect the get relative transform to all of this. Perfect. So I'm going to select all the shells nodes. I'm going to comment shells just to keep this somewhat tidy. Okay, now I'm going to start assigning different values to all of this. So the first tiling can have a value of like 1.6. The inner erosion strength can be the same, but the erosion area a value of 2. Again, you can play around with these values as much as you want. This is just going to give it an output that I expected and that I already experimented with. So I'm going to set the inflate base amount to 1.5. Inner erosion is going to stay 1 for all of them. So I'm going to go to the third shell down here, and I'm going to give it an inner erosion tiling of 1.7, inner erosion area of 2.02, inflate base amount of 3, and the inner erosion mask is going to stay the same. And then the fourth one is going to have an inner erosion tiling of 1.9, an inner erosion area of 2.05, an inflate base amount of 5, and the inner erosion mask is going to stay the same at 1. Okay, so now if I compile and save and I go into a viewport, you can see that these shells are giving a really nice look to the shader. But my outlines are a little bit too offset right now, so I'm gonna go back to the Painterly Shader tutorial and give it a default value of 5 like it was before. Okay, now they're a bit more sober. And if I go back to my map, I can find here the final Painterly material that I can just rotate around. And if I change my directional light, it's gonna be affected by it, of course. Now, if you create a material instance out of this Painterly Shader tutorial, you will have all the different parameters that you can play with to create different variations of this material. And that was it.
Thank you for sticking around for the whole length of this tutorial series. I hope you got something out of it and it was interesting to you as well as clear. If you end up pushing the feature of this shader even further or develop any projects with it, feel free to just tag me in there because I would love to see what you come up with. Alright, that was it for this tutorial series and I'll see you in the next one. Bye!